Hello friends, this is Dr. Sudhansh Sharma from School of Computers and Information Sciences. I welcome you all to this session of MCS 227, that is Cloud Computing and IoT. And in today's session we will be discussing about the cloud service delivery models and the cloud architecture. Now in the past session we had already discussed about different cloud deployment models. We had discussed about the public, private, hybrid, the cloud deployment models, and we had also discussed various characteristics of these models. Now objectives of today's session is to discuss about various cloud service models. Apart from this, we will be discussing about the architecture of the cloud. Now, the fundamental requirement of accessing any cloud service is the high-speed internet, wherein the user is actually accessing the services, be it infrastructure or platform or software as a service, through the high-speed internet. So, there is a user interface in between. We are having the networking devices, and thereafter we are having the service delivery models, and which are relying on the hardware resources. So, based on the speed of the internet, the user is able to access various services through the network technologies. Now that means if somebody wants to develop a software without accessing the person can scale up or scale down the requirements of the hardwares of the platform, be it any operating system, be it a database, be it the security model, and wants to develop the software independently, then the person may opt for the software as a service model. Now there are platform as a service and infrastructure as a service. Now many a times the companies are interested in developing and deploying the softwares, but they need to have the wide variety requirement of wide varieties of the softwares, network topologies, networking tools and instruments. So in order to take up all those things, the person or the company may utilize the services of the infrastructure available on the cloud. So the service delivery models are being categorized into infrastructure as a service, peripheral as a service, or platform as a service, and software as a service. Now herein we will start about the session. Let's look at the slides. Now in the last sessions we had discussed about the various characteristics of the public, private, community and the hybrid clouds on the basis of the demand for in-house infrastructure, ease of use, cost, security, ownership and management. Now we know that in the public clouds the things are available by the third party service providers, as a result of which there is no need of in-house infrastructure requirement, wherein in the private service model, private cloud deployment model, we need to have the dedicated in-house infrastructure, so that is mandatory in this. But in the community clouds we are having a number of organizations, though they are sharing the infrastructure requirements. Apart from this, in the hybrid part we are having the amalgam of the public and the private part, so the partial requirement of the infrastructure. So apart from this, we had also discussed about ease of use. Now since in the public cloud deployment model we are having totally third party involvement, as a result of which they are very easy to use. The public deployment models are very easy to use, but in the case of the private part, private cloud deployment models, the requirement of the operational IT staff is very much required, as a result of which it is not that much easy to use. We need to have the training of the IT staff so as to work with all those things. That means to manage the cloud in the private sector. Now we had already discussed all these factors and parameters in the last session. In this session we will be discussing about the cloud architecture, because I had already said that in order to deploy any cloud or in order to use any cloud service, the user is supposed to work with the user interface. So as a result of which, the architecture of the cloud is categorized into 4 layers. There is a client access layer, there is internet connectivity layer, cloud service management layer and the physical resource layer. Now the user is supposed to work at the cloud client access layer, Thereafter, based on the internet connectivity layer, wherein the network resources are being available through the high speed internet, the user is supposed to access the cloud service management layer, wherein the IaaS, PaaS and SaaS, that is software as a service, platform as a service and infrastructure as a service, are available as the infrastructure service modules, and these services are being actually accessed with the at the physical layer, wherein the physical servers, routers, data centers and all these things are being available. So the cloud architecture involves these 4 layers. Now, because the service management layer, the role is to provide the services. The services may be at the level of the software, or at the level of the infrastructure, or at the level of the platform. So there is a categorization of the services, wherein the software as service is actually explored by the cloud user, wherein the platform as a service is actually explored by the software developers, and the infrastructure as a service is provided and utilized by the infrastructure architect. So many times the users are supposed to work with the hardwares. They want to develop their application by using the servers, databases, network tools and components. So they are supposed to explore the infrastructure as a service. Based on the availability of the infrastructure or the virtualization of the infrastructure, the people are supposed to work with various application development. That means they can develop the application, they can deploy the application, they can choose the operating system, and they can work as they can use the cloud platform as a service. After that, many times the users are not interested in using actually they want to develop the software with quite ease. They don't want they want that everything should be managed by the third party. So at that point of time, the software as a service is the best option which is available for any cloud user. So on the basis of the software, the requirement of the user, that is the software or the platform or the infrastructure, we are having an SPI model wherein SPI model relates to software, platform, infrastructure as a service. Now every model, every service has got different layers. There are application layer, data layer, middleware, operating system, virtualization, storage, servers and networks. Now on the basis of the different models, we are having different options for to be managed by the users and by the service providers. Likewise, in the figure, it is very much visible that half of the image are dark and many places are quite fair. Now the dark section relates to the sections which are managed by the users, and the fair sections are relates to the sections which are managed by the service providers. Now if we think about infrastructure as a service, then the user is able to manage the application part, data part, middleware part and the guest operating system part, wherein the service provider is managing the virtualization, storages, servers and networks. But if we go to the platform as a service, then the role of the user is relating to the management of the application and data only, and the service provider is managing the middleware, guest operating system, virtualization, storage, servers and networks. But in case of software as a service, entire gambit, that is the application, data, middleware, guest operating system, virtualization, storage, servers, network, all are being managed by the service providers. So the software as a service option is very flexible. The things are ready to use. The user can directly work with the development of the software. But in the case the user wants to deploy the software by using its own, they want to craft the software as per their requirement. They want to graft the deployment techniques. They want to put control on the data. So in that case, the platform as a service is the option which is available for the person. So application and data are under the control of the user, and rest of the part, that is the middleware, guest operating system, virtualization, storage, servers and networks, are being taken care by the service providers. So this is the SPI model, which is actually letting us know that what is how much section is under the control of the user and how much section is under the control of the service provider. So there are different layers in the anatomy of the cloud, and these different layers are categorized as the physical hardware layer, virtualization layer, infrastructure layer, platform layer and the application layer. The application layer is wherein the web applications are working, and at this place, at this layer, the software as a service comes into the role, and there are some of the examples for software as a service. Likewise, Google Suite, we are having Microsoft Office 365, GoToMeet, NetSuite, Salesforce. These are some of the examples which works on the are the cloud technologies which are working at the application layer and generally used for the web application development, and these services are considered as software as a service. But so far as the platform layer is concerned, the software platform and data management tools are provided at this layer, and that means the user is having the control on how to deploy the software and how to manage the data. So that means at this layer, the platform as a service is accessed, and there are some of the examples. Likewise, Salesforce, Heroku, Cloud Foundry, Google Application Engine. These are some of the examples which are contributing to platform as a service. But infrastructure as a service is combined with three layers, wherein the role of infrastructure layer, virtualization and physical hardware layer comes into the picture. So far as the infrastructure layer is concerned, at this layer, the virtual computation power, virtual storage power, virtual network power is provided by as an infrastructure, and there are some of the examples. Likewise, Google Compute Engine, Rackspace, Microsoft Azure, Amazon Web Services. These are some of the examples which are contributing to the virtual provision of the infrastructure for virtual computation, virtual storage and virtual network. Apart from this, we are having the virtualization layer, which is providing hypervisors. Hypervisors are actually controlling the virtual machines and providing the user the facility to work with different operating systems at a time. So there are some of the examples. Likewise, we are having Zen servers and VMware and KVM. These are some of the examples which are facilitating the virtual layers and as an infrastructure as a service. And apart from this, all things are working at the physical level. We need to have the physical storage of the data. So we are requiring servers, we are requiring data centers, we are requiring hardware for the networking. So how actual computation, actual storage and actual networking is being done at the physical hardware layer. Now that means the data centers are actually the physical part wherein all the computation, storage and the networking is being handled. So the infrastructure as a service is comprised of three layers, that is the network infrastructure layer, virtualization layer and physical hardware layer. Platform as a service, PaaS, relates to platform as a layer, and software as a service is relating to application layer. So now we are supposed to discuss all these things in detail. As we had already discussed that in the case of infrastructure as a service, that means on-demand virtualization infrastructure. This is a service model wherein the physical infrastructure is being provided to the user, and it has got various benefits that the user can expand. If say if the company is trying to expand its working environment and wants more servers, more network tools, and more storage, then instead of purchasing the things explicitly, the person can directly go for infrastructure as a service and can access the virtualization storage, virtualized computing power, and virtualized databases. So virtualization, storage, servers, networks are all at the disposal of the company or at the person. So this service model is IaaS model, and the user has control over the application, data, middleware, and the guest operating system. So there is no control on the physical infrastructure, but the person has the control over the operating system, because the person can work may want to work with different operating systems at a time. The person wants to test, say, an application on iOS, on Android, on Windows, on Linux, different operating systems. So the person or the company wants to have the control that how the application is going to work on different operating systems. So under such situation, IaaS serves as a better option, because the company only wants to explore the hardware resources, that is the server part, data center part, your networking and storage issues are taken care by the third party. Rest of the things, likewise your operating system, your application, your data, are being handled by the person in parts or the company in particular. Now there are some of the services that are provided at the IaaS level. That means the computing, storage, network, and load balancing. Load balancing is one of the very important feature which is explored at the IaaS level, that is infrastructure as a service, because many times the say the load on the server is increased and the company is in the need of extra server. Then instead of purchasing or all those things, the company can pay per use model can be used by the company, and the load can be balanced and the server load can be handled. So computing, storage, network, and load balancing are the services which are regularly explored at the IaaS level. Now there are some of the advantages, because all the infrastructure is readily available in the data center, and it is pay per use model. The company or the user can directly explore that infrastructure instead of investing. That is, there is no fixed cost investment. It is a pay per use model, and the customer has to pay only for what they have used, and this strategy actually reduces the needless expenditure or investment on the hardware purchases. As a result of which, there is a reduction in the cost and elasticity in the resource utilization. That means you can expand your utilization, and you can contract your utilization on the basis of your needs. So that means this leads to the better resource utilization, as a result of which we are supporting the green computing, green IT, because the electronic garbage is not produced, because we are utilizing the infrastructure already available based on upon our use at the pay per use model. Thereafter, we are having some of the limitations of this infrastructure as service. Security is one of the important issue, because if the hypervisors are compromised, then then with the help of the operating system, the application, the data, all those things may be compromised. Apart from this, if we are using infrastructure as service, the interoperability, that means if one service provider, we are using services or infrastructure through one service provider, and we want to shift the application, data, all those things to other service provider, then interoperability issues comes into the picture. Apart from this, there are performance issues, because high speed internet is very much required. If there is some problem with the internet, then obviously the way and means to explore the hardware will be in the problem. So performance issues will be there if the high speed internet, if the performance of the internet is not okay, because the data is available on the distributed servers which are connected through the networks. Now there are some of the examples, that is Microsoft Azure, Amazon Web Services, Google Cloud Computing Engine. And we had already learned that this IaaS, that is on-demand virtualization infrastructure, is comprised of three layers, that is infrastructure layer, virtualization layer, and the physical layer. And we had also learned about that the virtual computing, virtual storage, and virtual networking is actually working at the infrastructure layer, and Google Compute Engine, Rackspace, Amazon Web Services, Microsoft Azure are some of the examples which are working at the infrastructure layer. Apart from this, VMware, Xen, and KVM are available at the virtualization layer, where hypervisors are working to provide the virtual environment. And at the physical layer, actual computation and the storage and networking issues are taken care, and therein the data centers are actually working. Now, the next service delivery model is your platform as a service delivery model. We had already discussed that when we are exploring the platform as a service delivery model, the user has control over the development of the application and the data. Apart from this, all other things, likewise your middleware, your guest operating system, virtualization, storage, servers, and networks are taken care by the third service provider. So by using the platform as a service model, the user can develop and deploy the applications, and the user don't have the control on actually the underlying infrastructures, that is servers, storage, network, operating systems, but the user has control on the deployed applications as well as the data related to that application. So that means the developer can build their application online by using different programming languages, and they can be supported on the different platforms and deploy their applications using the testing tools. So platform as a service is a very important component service model. It has got some of the advantages. Likewise, the application development and deployment is quite easy, and the teams are working all together. That means in the distributed environment, different teams are working on, say, same project, and they are going to club up the project and produce a single application. So application development and deployment can be in a collaborative environment, and this reduces the investment cost. So this applications can be scalable also, because say we developed say 2 modules, but later on we want to add on to say 2-3 more modules, then we are having the facility by using platform as a service deployment platform as a service model to scale up the applications. But there are some of the limitations. Likewise, your vendor lock-in is a key disadvantage. Likewise, in IaaS, when we are shifting from one vendor to another vendor, then there are some issues. So vendor lock-in is again a problem. When we are moving from one vendor to another vendor, then there are portability issues. Apart from this, there are security problems, and the flexibility is less, because the services provided by one vendor may not be available at the other vendor. So those services may not be working at when we are going to explore another vendor. So flexibility is less. Apart from this, again, platform as a service is highly dependent on the performance of the internet. And there are some of the examples to platform as a service, that is Red Hat OpenShift, Google Application Engine, Heroku, and Python Anywhere, Azure App Service, AWS Elastic Beanstalk. And at the platform layer, in the software platforms are available, and data management tools are available, and these things are available on platform as a service. Now lastly, we are having software as a service. In software as a service, all the things are being managed by the third service provider, that is your application, data, middleware, guest operating system, virtualization, storage, servers, and network. All are being taken care by the third party. Now, because these things are being taken care by a third party, the software developer need not to bother about the various issues that might be arising at the time of the development of the application. So likewise, the person can access the internet application with the help of, say, any browser on any of the machine, be it laptop or desktop or, say, thin client or mobile device or tablet or anything. By simply using the browser, the person can exactly work with the software. So all what is required is a high speed internet and a web enabled interface. Even without the software installation, the person can actually work with the software and develop the software with different programming language. So now these service providers by using SAS may develop a different type of services, may it be business management services or social media services, document management services, email services. So different services can be developed by using software as a service. So there are some of the advantages. Likewise, the user need not to install explicitly any software or database. So there is no client side installation. All things can be done at the cloud level. So this is highly cost saving because the user need not to arrange for any hardware, need not to make any arrangement for, say, security, need not to make any arrangement for the installation of the softwares, making settings. So maintenance is quite less. Apart from this, the software development is quite easy. And we can scale up or scale down the software based on upon our requirements. Apart from this, there is a feature of the multi-tenancy, which is referring to the sharing of the same application among the multiple users, and this improves the resource utilization. So the same application can be distributed among the multiple users, and this is quite cost effective also. But there are some of the limitations. Again, the security is an issue because entire data is at the disposal of the third party. So data leakage is possible in the SAS application. So while choosing the cloud service provider, we need to explicitly work on the legalities, that how the data will be managed, what are the provisions which are available, and service level agreement need to be monitored at very strictly. So there is no control of the data, and all are being managed by the third party. So in software as a service, the softwares are working, the user is working at the application layer, and it is generally related to the web application or the mobile development. And some of the examples of software as a service are Google Suite application, Salesforce, and we are having Microsoft Office 365. So Dropbox, Cisco WebEx, all are example of the software as a service. Apart from this, there are several other cloud services, likewise network as a service, desktop as a service, storage as a service, database as a service, data itself as a service, security as a service, and identity as a service. So all these services are available at the cloud services. Now, if we are going to explore network as a service, then we can explore routers, switches, and all those things, data centers. That is, NAS is a very important feature in cloud computing. Apart from this, we can virtualize our desktop by using desktop as a service. We can use explicit storages by using storage as a service, and database services by using DBAS, and there are some of the examples, likewise MongoDB is a very famous example. And the images, photos, audio, video, all are data. If somebody wants to access that data, then DAS is data as a service, and we can explore firewall and all other security measures from the protection of the malware and the spyware by using security as a service. So apart from this, identity as a service is also an important feature. If we are working in an organization with multiple persons, then in order to handle the identity of each and every person, then identity as a service comes as an option. I hope after going through this session, you are able to understand that what are different service delivery models. We had already learned about the deployment models. In this session, we had learned about the cloud architecture and the service models. So thank you very much.